Remember when Clone Robotics dropped their bombshell announcement about Clone Alpha? Man, that was one hell of a moment in robotics history. This wasn't just another metal box with servos. We're talking about a complete paradigm shift that had the entire tech world buzzing. The audacity of what these guys attempted was absolutely mind-blowing. And looking back now, it's wild to think about how they managed to push the boundaries of what seemed possible. So here's the thing that made Clone Alpha absolutely revolutionary. They threw the traditional robotics playbook straight out the window. While everyone else was obsessing over more powerful motors and sophisticated algorithms, Clone Robotics went completely rogue with their biomimetic approach. These madmen actually decided to recreate human anatomy from the ground up, building synthetic organs, artificial muscle systems, and skeletal structures that mirrored our own biology with terrifying precision. The engineering behind this machine was absolutely insane. Picture this: a polymer-based skeleton featuring 206 individual bone structures, each one meticulously designed to replicate human bone geometry and joint mechanics. The articulation points alone were staggering. We're talking about 164 points of movement just in the upper body section. Each hand-wrist-elbow combination delivered an incredible 26 degrees of freedom, giving Clone Alpha movement capabilities that made traditional industrial robots look like ancient relics. But wait, it gets even crazier. The real breakthrough came with their proprietary myofiber technology, essentially artificial muscles that operated on water pressure rather than electric motors. Think about that for a second. These synthetic muscle fibers weighed just 3 grams each, but could generate a full kilogram of force while contracting 30% of their original length in under 50 milliseconds. The fluidity of movement this created was absolutely mesmerizing, completely eliminating the jerky mechanical motions that plagued every other humanoid robot on the market. Powering this biological symphony was what they called their hydraulic heart system, a compact pump that circulated pressurized fluid throughout the robot's vascular network at 500 watts of power. This thing pushed 40 liters per minute of hydraulic fluid at 100 psi, essentially giving Clone Alpha a circulatory system that functioned remarkably similar to human physiology. The efficiency was staggering, especially when you consider how much power traditional actuator-based systems typically consumed. The control mechanisms were where things got really sophisticated. Clone Robotics integrated specialized valves called aquajets that managed fluid flow with incredible precision, while operating on just 1 watt of power each. This level of energy efficiency was practically unheard of in robotics at the time, and it allowed for the smooth, organic movements that became Clone Alpha's signature characteristic. Then there was the nervous system, and this is where my mind was completely blown. 4 depth cameras provided comprehensive visual input, while 70 inertial sensors monitored joint positions in real time. But here's the kicker. 320 pressure sensors embedded directly within the muscle fibers provided continuous feedback on force distribution and movement dynamics. All this sensory data got processed by distributed microcontrollers before being fed into an NVIDIA Jetson Thor GPU running Clone's proprietary CyberNet model. The result? Proprioceptive awareness that was genuinely human-like. Clone Alpha knew exactly where every limb was positioned in 3-dimensional space and could adjust its movements with incredible precision. Watching this thing move was like witnessing magic. The fluidity and natural grace were completely unlike anything we'd seen in robotics before. If you like this, make sure to hit that subscribe button, and don't miss next week's video where we'll dive into the most realistic humanoid robots of 2025. What really got people excited was the practical application potential. Clone Robotics preloaded Clone Alpha with 16 foundational skills right out of the box. We're talking about memorizing home layouts, tracking kitchen inventory, performing household maintenance tasks like vacuuming and table setting, even folding clothes with delicate precision. The party tricks were impressive too. Pouring beverages without spilling, preparing sandwiches, engaging in conversational dialogue, and performing natural handshakes that didn't feel like grabbing a mechanical claw. The customization platform they called telekinesis was particularly brilliant. Users could actually teach Clone Alpha new behaviors by physically guiding its movements and programming corresponding responses. This opened up incredible possibilities for personalization. Imagine training your household robot to handle specific tasks unique to your living situation or work environment. The story behind Clone Alpha was equally fascinating. CEO Dush Krishnan and CTO Lucas Click had been developing this vision for years, starting with smaller proof-of-concept projects that demonstrated their biomimetic approach. Their earlier prototypes, particularly the robotic hand with its rotating thumb mechanism and ball-catching capabilities, and the torso demonstrating realistic spinal and shoulder articulation, showed glimpses of what was possible with water-powered muscle technology. That decision to abandon traditional motors in favor of hydraulic muscle systems was absolutely crucial. It gave Clone Alpha a softness and adaptability that made it fundamentally safer for human interaction, while enabling more compact and efficient mechanical designs. The elimination of bulky actuators and gear systems allowed for sleeker profiles and more natural proportions. Clone Robotics founded their entire philosophy on biomimetics since launching in 2021, and Clone Alpha represented the ultimate expression of that vision. They weren't just building another robot, they were creating an artificial organism that could seamlessly integrate into human environments without requiring massive infrastructure changes. Of course, skeptics had legitimate concerns about production scalability and real-world reliability. The limited initial run of 279 units was clearly a strategic decision to refine the technology and gather user feedback before attempting mass production. Building individual components is one thing, but integrating everything into a cohesive, reliable system that could perform consistently over extended periods was an entirely different challenge. The applications extended far beyond household assistants. Industrial environments could potentially benefit enormously from humanoid robots that move naturally enough to work alongside human operators without requiring complete workflow restructuring. Manufacturing, healthcare, service industries. The potential was staggering. Looking back now, Clone Alpha represented something genuinely special in robotics history. The synthetic organ systems, advanced hydraulic muscle technology, and lifelike movement capabilities pointed toward a future where the line between biological and artificial systems became increasingly blurred. Whether it ultimately succeeded commercially or remained a brilliant technological stepping stone, Clone Alpha proved that radically different approaches to humanoid robotics were not only possible, but potentially transformative. The audacity of Clone Robotics' vision was remarkable, creating machines that didn't just look human, but functioned with biological principles. That legacy continues to influence robotics development today, inspiring engineers to think beyond traditional mechanical solutions toward more organic, adaptable approaches. Clone Alpha may have been just the beginning, but what a beginning it was. In the end, Clone Alpha did more than wow us with engineering. It challenged our idea of what a robot should be. Water-powered muscles, a synthetic circulatory system, and a nervous system of sensors proved that biology-inspired design isn't a gimmick, it's a path forward. The real question now isn't whether machines can move like us. It's where we'll invite them to move next. Our homes, our factories, our hospitals. So I'll leave you with this. When the next generation of biomimetic robots shows up at your door, are you ready to work with something that feels this close to alive? Tell me in the comments.